So let's continue our discussion of the graphs of functions. So what can we talk about whenever we're talking about the graph of a function? First off, we can talk about whether or not a graph indeed represents the graph of a function. A relation represents a function if whenever we draw a vertical line, it only can intersect that graph at most one point. So in other words, if we were able to draw a vertical line that intersects our graph at more than one point, then it does not represent a function. So if we take a look at this graph, does this represent a function? Can we draw a vertical line that intersects more than once? So there's a vertical line, and it intersects definitely more than once. Now, we could have drawn it over here, but that doesn't matter because we don't have to draw, not every vertical line, that is, not every vertical line has to intersect more than once. We just have to be able to find one. So this would have been sufficient. We just need to be able to draw a vertical line, and that vertical line intersect more than once. So this does not represent a function. Does this graph represent a function? So can you ever draw a vertical line that intersects more than once? And any vertical line that we draw intersects exactly once. So this does represent a function. What about this one? Can we draw a vertical line that intersects more than once? No matter where we draw that vertical line, it's going to intersect only once. So therefore, this is a function. What about this one? What do you think? If I draw a vertical line, I'm able to draw one that intersects more than once. So this is not a function. So here we have a function, and we want to know what point is on the graph if x equals 1. So if x equals 1, we just need to find f of 1. So everywhere we see x, we will replace with 1. So we have 1 squared minus 4 over 1 squared plus 2 times 1 plus 4. So the numerator will be 1 minus 4. The denominator will be 1 plus 2 plus 4. And so this is negative 3/7. So what point is on the graph? 1 is the x value, and negative 3/7 is the y value. Now for that same function, here we are told f of x equals positive 3/7, and we want to know what x is. So we look at x squared minus 4 over x squared plus 2x plus 4, and we want to know when that output is equal to 3/7. We can solve this by cross multiplying. So I can take x squared minus 4 times 7, and that gives us 7x squared minus 28 equals, we can multiply the 3 and the x squared plus 2x plus 4, and that will give us 3x squared plus 6x plus 12. Now this is quadratic, so let's get one side equal to 0. So let's move the 3x squared over. Let's subtract 6x from both sides and subtract 12. So this gives us 4x squared minus 6x minus 40 equals 0. Now everything here is divisible by 2. So let's divide both sides by 2. So this gives us 2x squared minus 3x minus 20 equals 0. Now we can solve this either by the quadratic formula, or we could try factoring. Since 2x squared only has one option, let's go ahead and try factoring first. So x and 2x. Now, the signs will be different, so let's try plus and minus. And 20, let's try 5 and 4. If we try 5 and 4, I already know this will not work because there's a common factor shared. So let's try 4 and 5. Now, if we check the outside and the inside, we get 8x minus 5x. That's the wrong sign. That gives us positive 3x. So let's switch the signs. So minus 4 and plus 5. And that should now work. So now, this means that x minus 4 equals 0, or 2x plus 5 equals 0. And so we have x equals 4, or x equals negative 5 halves. So this means that the points would be 4, 3/7, and negative 5 halves, comma, 3/7. If we use a graphing program like Desmos to graph our function, in this example, x squared minus 4 over x squared plus 2x plus 4, and we graph the 3 points, plot the 3 points that we found, then you will see 1 comma negative 3/7 is on the graph. 4 comma 3/7 is on the graph, and negative 5 halves comma 3/7 is likewise on the graph.